Hey, this is Dr. B, and let's take a nice deep look at acids and bases. You may have already learned that an acid is something that contains H plus in solution, a base is something that contains OH minus in solution, but there are plenty of substances that will affect the pH of a solution that have neither. So let's go into this in some detail. Those are our definitions. If it's got more H plus, it's an acid in that solution. If it's got increasing the concentration of hydroxide, it's a base. And there's a garden variety right there, hydrochloric acid. Absolutely. You throw that in, you're adding H plus to the solution because it dissociates totally. However, not every ion that contains H plus, ionic compound, I should say, totally dissociates. For example, hydrogen fluoride does form the hydrogen cation solution, but not much. Therefore, it will it's an acid, it just happens to be a weak one. There's also substances will lower the pH of that solution, like club soda, for example, adding carbon dioxide to water. It does lower the pH. How? It does so indirectly. Carbon dioxide reacts with water to make an acid. That acid happens to be a weak one, which only dissociates a little bit, so there's an indirect acid. Similarly, bases, if it's got hydroxide like sodium hydroxide, there you go, it's going to raise that pH. But there's some that do so indirectly. Ammonia has no OH minus, but it reacts with water to form it. In this case, a totally dissociated ion, right? The ammonium hydroxide, so you're adding OH minus. Sodium oxide reacts with water to form sodium hydroxide, which in turn is a base. So you do not have to have hydroxide to be a base, although that's a good place to start. The take-home message is that the common acids, some of the weak acids, and as well as the non-metal oxides are acids. We'll show you a couple more in a minute. Similarly, the common bases, ammonia, and some metal oxides are the bases. See how we've got things like carbon dioxide? That's a non-metal oxide. Carbon monoxide would be similar. These are substances which will be acids. If it's a metal oxide, however, it's a base. There is also temperature effects to consider with acids and bases. What would happen if you heat up water? Will it maintain a pH of 7? This is a question which is hard to avoid if you're a teacher because the answer is very interesting. If you take a solution of water, and you heat it up, it should dissociate more like most salts do, and it does. If it dissociates more, the concentration of H plus will increase. By virtue of this pH system, a lower number, right, 10 to the minus fourth is a bigger number, higher concentration than 10 to the minus fifth. So the pH goes down. Don't be confused into thinking the concentration of H plus is going down. It's going up. It's just that's how pH works. Simply for pOH, by the same argument, you get a lower pOH. So you might have water with a pH of 6.8, and yet it is neutral because both of these do so. You can't make H plus without making OH minus if you're water, so you will have a neutral solution. For analyzing pH by every ion we can think of, well, you've got your garden variety acids, and here's the big six. Hydrochloric, hydrobromic, hydriodic, sulfuric, nitric, and perchloric. You've got your strong bases, which are just the group 1 and 2 hydroxides. Lots of weak acids. The ammonium cation is a classic one. Gives up H plus, but not so much. Aluminum 3 plus will generate H plus in solution indirectly, as will magnesium, and transition metal ions like iron, for example. We're going to show some examples over here in just a minute. Phosphoric acid, where it's just 1 minus, losing that other H plus is possible, as is the third one, but they don't do so as readily as phosphoric does. Hydrogen sulfate with the -1 charge can lose one more H, but it does so weakly. And some non-metal oxides, for example, carbon dioxide, sulfur dioxide, etc. Weak bases included substances which do not have OH minus in it, but they react with water to make OH minus. The fluoride anion, the hypochlorite ion, sulfite, carbonate, bicarbonate, phosphate, hydrogen phosphate, cyanide, sulfide, nitrite. These are substances which in a solution will generate some OH minus, or to put it another way, they are generally the conjugate base of a weak acid. Acetate, similarly. So if you have sodium acetate, that should make the pH go up a little bit. There are a few ions which do nothing at all, and there's the metal oxides we referred to before. Chlorides, bromides, iodides, nitrates, perchlorates, sulfates, those are all just neutral ions which don't change the pH on their own. Here's some data. There's a lot of cations also that are just spectators, and we'll finish up with some data. I'm not going to go through these individually, but you should be able to make sense of why each one of these has they're all 0.1 molar solutions, which is nice. And here's a continuum of pHs, starting as low as 1.58, which is pretty strong for a 0.1 molar solution. Hydrochloric checks in at a pretty low pH. Sodium hydroxide, 12.2. Here's a transition metal ion, which will be acidic. Here's a potassium nitrate. Neither of those are of interest to us, so it's right about 7. Ammonia, as we pointed out, is a weak base and will raise the solution a little bit. And there it is right there. And anyhow, that's a nice complete look at acids and bases.